everyone. In this video, we are going through the part 2 questions. That's number 25 through 31 from the January 2020 Geometry Regents exam. All right, number 25. In the diagram below, right triangle PQR is transformed by a sequence of rigid motions that maps it onto right triangle NML. Write a set of 3 congruency statements that would show angle-side angle congruency for these triangles. There's actually a couple right answers that we could get here, but I'm going to start off using angle Q and angle M. Those are marked off already in my picture, so I'm going to say we must know those are congruent. That takes care of the first angle. Now I need a side, so I'm going to say that QP is congruent to MN. And now we need another angle. So when you're using angle side angle, the side that we have marked off as congruent must be directly between the two angles. So I need angle P and angle N to be congruent. And now I have angle side angle represented in my pictures. Keep in mind, you could have had different answers to this question. You could have potentially, if you go in here, used side QR and angle R. That would also give you angle side angle. All right, in 26, Diego needs to install a support beam to hold up his new birdhouse. The base of the birdhouse is 24.5 inches long. The support beam has an angle of 38 degrees with the post, and we want to find the length of the beam. This is a lot of information. Really, all we need to do is use SOHCAHTOA here. Okay, so the 38 degrees, the opposite side is where the 24.5 is. The adjacent side is blank. And the hypotenuse is where X is. So since there is something written on the opposite side, that's O, and the hypotenuse, H, we are going to use sine. So sine of 38 equals the opposite over the hypotenuse. And I would suggest writing that as 24.5 so that we can type it into our calculator easier. All right, let's cross multiply. So X times sine 38 is just that, X sine 38. 24.5 times 1 is itself, and we're going to divide both sides by the sine of 38. And let's type that into our calculator. 24.5 divided by sine 38, and we're going to hit enter. This problem is asking us for X to the nearest inch. That means the nearest whole number. So X is 40 inches in this case. 27, a rectangular tabletop will be made of maple wood that weighs 43 pounds per cubic foot. Before I go in any further, I just want to take note that that is a unit for density because it's a mass over a volume, pounds per cubic foot. The tabletop will have a length of 8 feet, a width of 3 feet, and a thickness of 1 inch. Determine and state the weight of the tabletop in pounds. Anytime you see a question that has something to do with a 3-dimensional shape, particularly volume questions in this case, or density questions, check the units. So I see cubic feet, 8 feet, 3 feet, but then I see 1 inch. We need all of our units to match, so I'm going to change this to 1/12 of a foot. So let's find the volume here. So the volume is length times width times height, or area of the base times height you could use. So I have 8 times 3 times 1/12. So I know that the volume of the tabletop is 2 cubic feet. Now I'm going to take that and plug that into the density formula. So we know our density is 43. We don't know the mass. That's what we're looking for. Mass is weight. And we know the volume is 2. If I cross multiply here, I'm going to get that the mass is 86 pounds. In the diagram below of circle O, secant ABC and tangent AD are drawn. CA is 12.5, so I'm labeling as I read here. CB is 4.5. Well, that must mean this is 8 over here, right? If the whole thing is 12.5. Determine and state the length of DA. So when you have a secant and a tangent, the rule is the outer times the whole thing, and that's in terms of the secant, is tangent squared. So the outer part of the secant is 8, the whole thing is 12.5. And tangent squared is, we'll use x there, x squared. All right, so in our calculator, let's multiply 8 times 12.5. I get 100 is x squared, and then x comes out to be 10, or dA is 10. Okay, for number 29, given segment MT below, use a compass and straight edge to construct a 45-degree angle whose vertex is at point M, and we're going to leave all of our construction marks. So I'm going to be using my safety compass to complete this. And what I'm going to do first is I'm just going to bold, just to make using the compass a little easier, the points M and T so I can see them a little bit better through the holes of the compass. Okay, so we are basically given a line segment, and if you think about a straight angle, you have 180 degrees. So we need to find a way to make this 45. So the first thing I can think of is, well, if this is a 180 degree angle, let's have that and get 90 degree angles. Okay, and if you think about that again, 90 and 45 are going to have a relationship there too. So I'm going to put the gold piece, this gold ring of my compass, on the first endpoint. And I'm basically going to do the perpendicular bisector of MT to cut it in half. So I'm going to look for any point on my compass that's kind of close to T. It could be exactly on T. We just don't want it too close to M. Okay, so whatever one you're going to use, it doesn't really matter so much. I'm just going to pick this one that's by W. I'm going to make a nice big kind of backward C shape. Okay, a nice big arc. If you want, you could write down like, okay, I used the one before W to help you remember which one you used. Okay. Then what we're going to do is we're going to reverse this, and we're going to put the gold ring of our compass on T. Okay, again, center it nicely over that bolded point. I'm going to find the same letter, so before W, and I'm going to make a nice big arc the other way. And I'm going to use my compass now as a straight edge to connect these two intersections. Okay, so you want your arcs to be big enough so that there's two intersections. And basically what I did here, I'll erase this extra. Okay, I always do construction in pencil, or I'm using erasable pen. Basically what I have here is I've created a 90-degree angle. Now I want a 45-degree angle, and I want the vertex to be at point M. So imagine here for a second, kind of if you're following where I'm tracing the pen, I need this to be a 45-degree angle. So one way I can think about doing this is by creating a triangle. And if I create an isosceles triangle, just to draw this off to the side for a second, if I have a right triangle, and it's isosceles as well, the two remaining acute angles have to be 45 degrees each in order to get a sum of 180 degrees. So what I'm going to actually do, I'm going to bold this intersection right here, and I'm going to figure out how big this is from M to this center point. So I'm going to put the gold ring on the center point, and I'm going to find a hole in my compass that lines up exactly with M. So I see one right here between H and L, and I'm going to make a little arc to show I measured it. Then I'm going to put the gold piece of my compass here. I'm going to use the same letter on my compass. You could have even just made one big arc to do that. And if I can now connect those 2 points, basically since I use the same letter on my compass, these two line segments are congruent to one another, which means these two angles are congruent to one another, and they must each be 45 degrees because we need this to be a 45, 45, 90 triangle, okay, an isosceles. If you were thinking originally, and this construction is complete by the way, but if you were thinking originally, why can't I take the original line segment, bisect it, which is what we did, and then bisect it again? Okay, and that would create a 45-degree angle. That's true. You'd probably get partial credit on that on the Regents, but look where the vertex of that angle is. It's going to be at the center point. The key in this problem is that it wants the vertex at point M. Okay, number 30, in triangle XYZ shown below, medians XE, YF, and ZD intersect at C. If CE is 5, YF is 21. Okay, so I'm just going to put like a big bracket here. And XZ is equal to 15. We want to find the perimeter of triangle CFX. So I'm going to just highlight what we're trying to find the perimeter of. All right, so let's talk about what a median is. So a median is basically a line segment that starts at a vertex and it goes to the midpoint of the opposite side. I can use that information to help me find the length of XF because that means that F is a midpoint. And now I know that that's split 7.5 and 7.5. If I now want to find the length of XC or the length of FC, the medians of a triangle, when they intersect, they cut each line segment into a 2-to-1 ratio. So I can tell that XC is going to be 10 because 10 plus 5 gives me the total of 15. And when I think about it, 10 is 2/3 of 15. Or you could think about it that it's just double 5. When I look for FC, I see that I'm looking for the smaller segment of the whole entire median. So if I look at the whole median FY, it's 21. I'm looking for the smaller piece here. So I'm really looking for 1/3 of it. And that comes out to be 7. 2/3 of it would have been 14, which goes over here. So again, I'm using 1/3 because I know that the ratios are 1:2 in this case, since the smaller piece comes first. And that's 1/3 of the entire segment. So now if I want to find the perimeter, it's 10 plus 7 plus 7.5. And we get our total here. There we go, 24.5. All right, for our last question in this part, determine and state an equation of the line perpendicular to 5x minus 4y equals 10 and passing through the point 512. Well, let's definitely try and figure out what the slope of this line is. So I'm going to subtract 5x onto the other side. I'm going to try and isolate that y value. And I'm going to now divide everything by -4. So I have y equals 5/4x minus 10/4. The slope of this line is 5/4, so the slope of a perpendicular line would be -4/5 because the slopes of perpendicular lines are negative reciprocals. Now let's use that slope and our point, and we're going to plug them into point slope form, which remember looks like this. Y minus y1 equals m parentheses x minus x1. So y minus 12 equals -4/5 x minus 5. Close the parentheses, and that's our answer. It is not necessary to put this in slope-intercept form. You certainly could, and that would be correct. But to me, it's not necessary to do the extra work and risk making a mistake. Okay? You can head to the next video in this playlist to catch the answers to the Part 3 and Part 4 questions from this Regents exam.